For centuries, people looked up at the night sky believing that most of the solar system had already been mapped. We discovered the planets, catalogued countless asteroids, tracked comets, and built powerful telescopes capable of peering billions of light years into space. It felt as though the nearby universe held very few surprises. But one extraordinary observatory has already proven that assumption wrong. In just a single night of early observations, the Vera C. Rubin Observatory identified more than 2,000 previously unknown asteroids. None of the newly discovered near-Earth objects pose a danger to our planet, and that is reassuring. Yet the discovery raises a far more unsettling question. If thousands of objects were hiding in plain sight until now, how much of our own cosmic neighborhood has remained invisible simply because we lack the right tools to see it? The solar system is anything but empty. Between the planets lies an enormous population of rocky fragments, icy worlds, ancient debris, and wandering comets. Most will never come close to Earth. Some preserve clues from the earliest days of planetary formation, making them invaluable to science. Others deserve careful monitoring because their orbits could eventually bring them closer to our planet. Understanding this constantly changing environment requires more than a powerful telescope. It requires one capable of watching enormous regions of the sky over and over again. That is exactly what makes the Rubin Observatory different. Instead of focusing on a single target for long periods, it repeatedly surveys vast portions of the night sky. By comparing one image with the next, astronomers can immediately recognize objects that have shifted position. A tiny point of light that appears stationary one moment and moves the next suddenly becomes something entirely different, a previously unknown asteroid, a distant comet, or perhaps something even more unusual. What makes these first discoveries remarkable is not that the asteroids suddenly appeared. They had been traveling through the solar system all along, silently orbiting the Sun while remaining unnoticed. Rubin simply had the speed, sensitivity, and field of view needed to reveal what had always been there. Its first observations remind us that our understanding of the solar system is still incomplete, even after decades of exploration. For generations, astronomy relied on instruments designed to study specific objects in extraordinary detail. Those telescopes transformed our knowledge of planets, stars, and galaxies, but they could only observe relatively small portions of the sky at any given time. Meanwhile, the universe continued to change. Asteroids crossed invisible paths. Comets brightened and faded. Rare cosmic events unfolded without anyone watching. If an object passed through the wrong part of the sky at the wrong moment, it could disappear forever without being recorded. Rubin approaches the sky from a completely different perspective. Rather than taking isolated snapshots, it creates an ongoing record of motion. Every new observation is compared with previous ones, allowing even faint moving objects to stand out. A tiny shift from one image to the next may reveal a forgotten remnant from the birth of the solar system or an entirely new object that has never before been catalogued. This capability represents far more than another scientific achievement. It changes how humanity watches its own neighborhood in space. Discovering thousands of previously unknown asteroids in such a short time suggests that millions more may still be waiting to be identified. The familiar picture of the solar system as a handful of planets surrounded by mostly empty space is giving way to something far more dynamic, a vast environment filled with countless objects constantly moving through the darkness. Rubin is becoming much more than a telescope. It is evolving into one of the world's most powerful systems for detecting change. Every observation strengthens our ability to understand the solar system, improves planetary defense efforts, and expands the inventory of objects sharing our corner of the galaxy. Sometimes the greatest threat is not the object we already know about, but the one that has remained hidden until now. The most astonishing part is that these discoveries came before the observatory had even begun its full scientific mission. If thousands of unknown asteroids could be revealed almost immediately, what might years of continuous observations uncover? The answer could reshape our understanding of everything moving through the solar system. Unlike traditional observatories built primarily to zoom in on distant targets, Rubin was designed to watch the sky on an enormous scale. Its revolutionary design allows it to capture massive areas of space while maintaining remarkable detail, making it one of the most effective survey instruments ever created. And this is only the beginning. As its decade-long mission unfolds, the observatory is expected to uncover millions of new objects, transforming our view of the solar system in ways that were impossible only a few years ago. Rubin's greatest strength lies in the way it observes the universe. While many famous telescopes concentrate on tiny regions of space to reveal extraordinary detail, Rubin was built with an entirely different purpose. Instead of staring deeply into one small patch of the sky, it continuously surveys enormous areas, creating a living record of everything that changes from night to night. At the heart of the observatory is the largest digital camera ever constructed for astronomy. Its incredible resolution allows a single image to capture a vast portion of the heavens while still revealing faint objects that older surveys could easily overlook. But sharp images alone are not enough. The real breakthrough comes from repetition. Rubin photographs the same regions again and again, comparing each new observation with those taken before. If a faint point of light shifts even slightly, sophisticated software immediately recognizes that something is moving. That simple idea transforms the night sky into something far more dynamic than a collection of still photographs. Every comparison creates another frame in an ongoing movie of the solar system. Objects that once blended into the background suddenly reveal themselves through motion. Tiny asteroids, distant comets, and icy bodies drifting beyond the planets become much easier to identify because they cannot hide from repeated observations. This is why the first discoveries are only a preview of what is coming. Scientists expect Rubin to uncover millions of previously unknown asteroids during its decade-long mission. These discoveries will include countless main-belt asteroids, near-Earth objects, Trojan asteroids traveling alongside planets, and distant icy worlds occupying the outer reaches of the solar system. Many are too faint, too small, or too fast-moving for earlier surveys to detect consistently. Perhaps even more exciting is Rubin's ability to discover visitors from beyond our solar system. Objects like Oumuamua and Comet Borisov demonstrated that material from other star systems occasionally passes through our cosmic neighborhood. Before observatories like Rubin, these travelers could easily slip past unnoticed, giving astronomers only a brief opportunity to study them before they disappeared forever. By scanning the sky repeatedly, Rubin dramatically increases the chances of spotting such visitors much earlier, allowing scientists valuable time to investigate their origins. For the first time, humanity has the opportunity to build an almost complete inventory of the constantly changing solar system. Not just the major planets or the brightest comets, but the countless fragments, ancient leftovers, and wandering bodies that quietly move through space every day. Each discovery fills another gap in our understanding of how the solar system formed and how it continues to evolve. There is something both reassuring and unsettling about this new capability. On one hand, identifying more objects makes Earth safer by improving our ability to predict future encounters. On the other hand, every new discovery reminds us that the sky is far busier than we once imagined. What appeared calm from Earth is actually filled with continuous motion, as countless objects follow invisible paths around the Sun. Yet Rubin is doing far more than searching for asteroids. Every exposure also captures distant galaxies, exploding stars, variable stars, glowing nebulae, and the faint structures surrounding the Milky Way. A single image may contain nearby rocks crossing the foreground while recording light that has traveled billions of years from the distant universe. Multiple scientific investigations can emerge from the same observation, making every image a remarkable collection of discoveries waiting to be explored. As the observatory continues its mission, the amount of information it produces will become staggering. Night after night, it will generate an enormous stream of new observations, creating one of the largest astronomical datasets ever assembled. No individual scientist could examine every image manually. Instead, advanced computer systems will analyze the data, identify unusual events, and alert astronomers whenever something unexpected appears. The greatest mystery is not whether Rubin will continue making discoveries, it almost certainly will. The real mystery is what those discoveries will be. A newly identified near-Earth asteroid years before it poses any concern, a comet arriving from the distant edge of the solar system, another interstellar visitor passing briefly through our neighborhood, or perhaps an entirely new type of astronomical event that challenges what scientists thought they understood. That is why Rubin's early observations represent much more than impressive engineering. They mark the beginning of a new era in astronomy, one where the universe is no longer viewed as a collection of isolated snapshots but as a constantly changing environment. For the first time, we have an observatory designed not only to see the cosmos, but to watch it evolve in real time.